Solving one-step inequality notes. We have solved equations at the beginning of the year. Now we're going to solve equations that have inequalities. So things with greater than and equal to, less than or equal to, greater than, less than, etc. The rules are very similar to solving equations. In this inequality, we have x plus 4 is greater than or equal to 9. I would like to solve for x, so I will simply subtract 4 from both sides of the inequality. Subtracting 4 on this side cancels it out. Subtracting 4 from 9 leaves me with 5. Notice that the symbol keeps pointing in the same direction. For example 2, we have x minus 6 is less than or equal to 8. Solving this for x, I would add 6 to both sides of the inequality. The symbol stays in the same direction, and 8 plus 6 is 14. For the third example, we have x plus 3 is greater than negative 4. To solve this for x, I would subtract 3 from both sides, leaving me with x is greater than negative 7. Notice again, the symbol stayed in the same direction. These are also solving using one-step inequalities. This time I have 3 times x is greater than or equal to 9. So to solve for x, I would divide both sides by 3, leaving me with x is greater than or equal to 3. Notice the symbol stayed in the same direction. For my next example, I have 4x is less than or equal to 20. To solve for x, I would divide both sides of the inequality by 4. X would be less than or equal to 5. Notice again, the symbol stayed pointing in the same direction. For my next example, I have 6x is greater than negative 30. Divide both sides by 6. I get x is greater than negative 5. Remember, a negative divided by a positive is negative. Again, the symbol stayed the same direction. Now, here's the wrinkle. Sometimes when solving a one-step inequality, we will need to change the direction of the inequality symbol. And that is any time that we need to multiply or divide by a negative number to solve the inequality. In my first example, I have negative 3x is greater than or equal to 9. In order to solve this, I must divide both sides by negative 3. Anytime when you're solving an inequality and you divide both sides by a negative number, that necessitates changing the direction of this symbol. So my answer would be x is less than or equal to negative 3. This only happens when we divide or multiply by a negative number on both sides of the inequality. My second example, negative 4x is less than or equal to 20. In order to solve this, I would divide both sides by negative 4. When you divide both sides by a negative number, the symbol must change directions. So my answer would be x is greater than or equal to negative 5. The sign has changed directions. For my third example, again, to solve for x, I would divide both sides by negative 6. Since I divided both sides by a negative number, the symbol must change directions. So my answer would be x is less than 5. Notice if the sign in the original problem does not have an equal sign, the sign in my solution does not have an equal sign either. But in the previous two problems, since both started out with an equal sign in them, they both end up with an equal sign in them. Now, to solve this equation, my original inequality is x divided by 3 is greater than or equal to 4. Well, the opposite of dividing by 3 is multiplying by 3. So I must multiply by 3 on both sides. Now, since 3 is a positive number, and I'm multiplying both sides by a positive number, the symbol does not change directions. Looking at my next example, you'll notice that we have x divided by negative 3 is greater than or equal to 4. To solve this inequality, I would have to multiply both sides by negative 3. Anytime you multiply or divide both sides of an inequality by a negative number, the sign must switch directions. So greater than or equal to becomes less than or equal to. And 4 times negative 3 is negative 12. My last example has x divided by 3 is greater than or equal to negative 4. To solve this equation, I would multiply both sides by 3, because that is the opposite of dividing by 3. Because I've multiplied by a positive number, though, the sign stays the same direction. So my answer would be x is greater than or equal to negative 12. Notice it didn't matter that the answer was negative 4 to start with. That did not cause me to change the sign. The only thing I'm worried about is what do I multiply both sides of the inequality by. If it's a positive number, the symbol stays the same. If it's a negative number, the symbol must switch. Let me show you an example of why we need to switch the sign of the inequality. I think we would all agree that 6 is greater than 4. If I add 2 to both sides of this inequality, I would get 8 is greater than 6. Notice this is still a true statement. So adding 2 to both sides does not affect the inequality. The same thing is true about subtracting 2 from both sides. 8 minus 2 is back to 6. 6 minus 2 is back to 4. You'll notice this is still a true statement. 6 is greater than 4. This time I'm going to multiply both sides by 2. 6 times 2 is 12. 4 times 2 is 8. You'll notice 12 is greater than 8. So adding, subtracting, and multiplying by positive numbers does not change the direction of the sign. This time, I'm going to multiply by negative 2. And I must do it to both sides to keep it true. 12 times negative 2 is negative 24. 8 times negative 2 is negative 16. Now, if I kept the symbol the same, negative 24 is greater than negative 16. That is not true. Negative 16 is greater than negative 24. The more negative something is, the smaller it is. So in order for this to be correct, I would have to switch the direction of this sign. So that is why when we multiply both sides of an inequality by a negative number, I am required to switch the sign in order to keep it true. The same thing is true about division. If I divide both sides of this inequality by negative 4, negative 24 divided by negative 4 is 6. Negative 16 divided by negative 4 is 4. Notice if I keep the sign the same, I am now claiming that 6 is less than 4. And we all know that is not true. So because I divided both sides by negative 4, I need to switch the direction of the symbol in order to keep it true. So in conclusion, anytime we multiply or divide by a negative number in order to solve an inequality, we must change the direction of the inequality. Multiplying or dividing by a positive number has no effect over the inequality.